Hey all, it's Carl, and this is week 5 in MyStatLab, problem number 3, and I wanted to go over multi-generational families. This table right here, this contingency table, as you can tell, it's just it looks like general survey data that we have here showing 2 adult generations, 2 skip generations, 3 or more generations, essentially different various household components with families, parents and children, grandparents and their grandchildren, or all of them, all the above. And then we have this broken down by race. And so what I wanted to show you is just to get a sense of how this is calculated for the purposes of probability. What we call this in statistics is a contingency table. And I've already done the math here. It's very simple arithmetic. I wanted to go over it real briefly. Our first question is the probability of a multi-generational family being white. And what does that mean? That means that if you randomly select out of the 532 in this sample, if you randomly select one multi-generational family, that there is a 27% chance, or 0.27, depending on how you want to phrase it, probability or chance that that randomly selected family will be white, with a race of white. So, just to give you a sense, and it's just simple, what we have done in this case to find that out is just take our numerator in this division is the overall population with a race of white, and our denominator is the total across all races. And that's how we find out this first question right here. And then stemming from that, our second question is the probability of multi-generational families being 1, a race of black, and 2, consist of 3 or more generations. So what we're going to do with this, and you'll notice that this is a very small number. And essentially you can tell why, because F9, our cell F9, the denominator stayed the same. This is across all multi-generational families. We want to know that. So the 532 is still there. But our numerator is different because we're looking at a very discrete, specific group of individuals, or families rather. Those families that have a race of black and consist of 3 or more generations. And so that is this value right here. So as you can imagine, 21 over 532 gets you a very small number. And what this means is essentially, as I've said before, is that if a family is taking at random out of this 532 sample, that there is a 3.9% probability or chance that that family will be 1, or will have 1, a race of black, and 2, consist of 3 or more generations. And just to give you a quick sense too, because you can notice how in this one we went from 1 condition in a question, and here we went to 2 conditions. So you can naturally think that which one is the joint probability? Well, obviously this one is a joint probability because it means 2 conditions must be met. There is a joint, it's in the name, there's a joint probability. Whereas with our first one, it's a marginal probability because it's 1 condition is met over the whole group. And so marginal probabilities are pretty cut and dry in statistics. Just taking a simple value of what you're looking at, usually this can be the numerator, and then your denominator is aforementioned, is right here. So just giving you a very basic fundamental concept of what probability is like within a contingency table. So I hope this helps you guys out, and let us know if you have any questions. Thanks much.